Not slightly wrong, completely wrong. A new study published in the monthly notices of the Royal Astronomical Society is challenging one of the most confident conclusions in modern astronomy. And by the time we reach the end of this video, I'm going to tell you something about that famous photograph, the one that supposedly proved the black hole exists, that will genuinely make you question everything. Welcome to Cosmic Story Lab. Pull up a seat. This one changes the story of our entire galaxy. Before we dive in, every fact in this video comes from peer-reviewed research and verified scientific sources, including the Royal Astronomical Society, phys.org, and Universe Today. This is a real, active scientific debate. The ideas here haven't been proven or disproven yet. That's what makes it so fascinating. Science is honest about what it doesn't know. And so are we. Let's start with what we've believed for decades. At the heart of the Milky Way, about 26,000 light years from Earth, sits an object called Sagittarius A star. Most people write it as SGR A star. And for as long as modern astronomy has studied it, the conclusion has been overwhelming. It's a supermassive black hole, roughly 4 million times the mass of our Sun. The evidence seemed airtight. Astronomers tracked a group of stars called the S stars, real stars with real orbits, looping around the galactic center at speeds reaching several thousand kilometers per second. According to everything we know about gravity, only something incredibly massive and incredibly compact could make stars move like that. A black hole fit perfectly. Then, in 2022, the Event Horizon Telescope collaboration released an image that seemed to seal the case forever. A glowing ring of superheated gas. A dark shadow at the center. The world celebrated. The black hole was real. Except, what if that shadow doesn't mean what we think it means? This is where it gets genuinely strange. An international team of researchers, led by Valentina Crespi of the Institute of Astrophysics La Plata in Argentina, published a study proposing something radical. What if Sagittarius A star isn't a black hole at all, but instead an enormous, invisible clump of dark matter? Now, dark matter isn't science fiction. It's one of the most accepted concepts in modern physics. According to NASA and decades of astronomical research, dark matter makes up roughly 85% of all mass in the universe. You can't see it, you can't touch it, but we can measure its gravitational effects, and those effects are everywhere. What makes this new theory different is the specific type of dark matter it proposes. The researchers suggest it's made of fermions, light subatomic particles that, under the right conditions, could compress together into an incredibly dense, compact core. Dense enough to make stars orbit at thousands of kilometers per second. Dense enough to bend light so severely it creates a dark shadow surrounded by a bright ring. Dense enough, in other words, to look exactly like a black hole, without actually being one. As lead researcher Valentina Crespi told BBC Sky at Night magazine, quote, "The dense dark matter core can mimic the shadow because it bends light so strongly, creating a central darkness surrounded by a bright ring. Think about that for a moment. The photograph we celebrated, the image that made headlines around the world, it might be showing us something we've never seen before and misidentifying it as something familiar. Before we go further, if this is already making your head spin, hit the like button. It takes 1 second, and it genuinely helps this channel reach more curious minds. And if you're not subscribed yet, come join us. We do this every week. Okay, back to the center of the galaxy. Here's where the implications get truly enormous. If this theory is correct, and scientists are careful to say it's a theory, not a proven fact, it doesn't just change our understanding of Sagittarius A star. It rewrites the story of how entire galaxies form and evolve. The standard model of galaxy formation says that supermassive black holes sit at the centers of most large galaxies, acting as gravitational anchors that shape everything around them. Remove that black hole, and the whole model shifts. The fermionic dark matter model proposed by Crespi and her team suggests something even more profound. Rather than a galaxy being shaped by a central singularity, a black hole, the Milky Way might be held together by a continuous structure of dark matter that stretches from the very center all the way to the farthest edge of the galaxy. The core and the outer halo wouldn't be two separate things. They'd be two parts of one enormous, unified entity.
As co-author Dr. Carlos Argüelles explained, we are not just replacing the black hole with a dark object. We are proposing that the supermassive central object and the galaxy's dark matter halo are two manifestations of the same thing. One thing. From the center to the edge. The entire galaxy, held together by a single invisible structure we've barely begun to understand.
Now, and this is important, most astronomers are not ready to abandon the black hole explanation. Not yet. The black hole model has been tested from many different angles over many decades. The S-star orbits, the Event Horizon Telescope image, radio emissions, X-ray flares from the galactic center. All of it fits the black hole model well. What researchers like Crespi are doing isn't saying the black hole is definitely wrong. They're saying something more scientifically honest. The fermionic dark matter model can explain the same observations just as well. And that means we might not have enough evidence yet to truly distinguish between them. As Universe Today noted in their coverage of the study, the dark matter explanation can account for the S-star orbits. The galaxy's rotation curve has measured by the ESA's Gaia spacecraft. And crucially, it can produce shadow-like features in images that are compatible with what the Event Horizon Telescope actually captured. This is how real science works. Not with certainty, with competing models, with honest uncertainty, with the humility to say we might be looking at something we've never truly understood. Let's zoom out for a moment, because there's a bigger question hiding underneath all of this. Why does it matter whether it's a black hole or a dark matter structure? Because the answer changes our place in the story. A black hole at the center of the Milky Way is terrifying and magnificent in a distant way. It's an object of pure gravitational destruction, something that devours everything that falls in, something that exists at the edge of what physics can describe. But a dark matter structure, something that spans the entire galaxy from its beating heart all the way out to where our solar system drifts, that's something different. That's the skeleton of our home. It's not something out there at a safe distance. It's the invisible framework that everything we've ever known is embedded in. Every star, every planet, every atom in your body.
floating inside a dark matter structure whose full nature we are only just beginning to question. We started this video with a question. What if Sagittarius A star is not a black hole? And here's the honest answer science gives us right now. We don't know for certain. The black hole model is still the leading explanation, and it might be right. But a peer-reviewed study published in one of astronomy's most respected journals has shown that a dense structure of fermionic dark matter could explain everything we've observed just as convincingly. The photograph that made headlines? It may not be proof of what we thought.
The orbiting stars? They could be dancing around something stranger than a singularity. The galactic center? It might be the heart of something vast and invisible that we've only just begun to see. And here's what I promised you at the start. The thing about that famous photograph that changes everything. The Event Horizon Telescope image doesn't show a black hole directly. It shows a shadow. And according to this new research, a sufficiently dense dark matter core would cast the exact same shadow. We may have photographed the proof of our own misunderstanding. Science doesn't always give us certainty. Sometimes it gives us something better, a deeper question. Thank you for watching all the way to the end. That means more than you know. If this video made you see our galaxy differently, share it with someone who loves space. And subscribe if you haven't. We go somewhere extraordinary every single week. Now here's your question for the comments. If the center of our galaxy turned out to be dark matter instead of a black hole, would that make the universe feel more or less mysterious to you? I want to know. Until next time, keep looking up.